we're going to look at the measure of central tendency. This is where we're going to see what's going on in the middle of our data. This is the mean, median, and mode. We'll start with the mean. You're going to add up all your numbers, all your data, and divide by the number of numbers that you have, or the number of data. In fancy math symbols, looks like this. We've got our sum on the top, and we're dividing by n, the number of data. Let's look at an example. Here we've got exam scores for class 1. I'm just going to add all these numbers together, and I'm going to divide by 6 because there are 6 numbers. You want to be careful when you type this in your calculator. Make sure that you put parentheses around the numerator if you're going to do it all in one step, or it might be easier to get your answer for the numerator and then divide by 6 in 2 steps. You want to follow regular rounding rules or whatever rules are given to you in the directions. When I typed this in my calculator, I got 77.83 with a repeating 3. So just remember that we use a repeating to go on top of that 3 to show that it keeps on going forever and ever and ever. We also have what's called a weighted mean. This is where things aren't all even. For instance, your grade in this class. Exams are worth 50% of your total grade, while the homework is only worth 10% of your total grade. Exams are worth a lot more, so they have a heavier weight. For my example, though, we're going to calculate a GPA, and this is also how your GPA is really calculated. It's weighted by the number of hours that you have. So a lab that's only worth 1 hour doesn't carry as much weight as the class that might be worth 4 hours. So in my example, someone has 7 hours worth of A's. They got a B and 9 hours worth of classes, a C and 6 hours worth of classes, etc. Now I can't put A, B, C, D, and F in my formula because they're letters, not numbers. So I need to remember that the A is the same thing as 4. A B is the same thing as 3. A C is 2. A D is 1. And an F counts as 0. You don't get any credit for that. So when I go to plug this in my formula, it's going to look like this. Here's my term for A, 7 hours, and an A is 4. B, 9 hours, and a B is 3. Here's my C term, 6 hours, and a C is 2. Now don't forget about your F. It's not going to matter on the numerator, but it will change the denominator. The denominator is the total of all the weights, or in this case, the hours. So I do need to make sure to include F. That's why it's a good idea not to just leave it off of the numerator. You might then forget it on the denominator. I'm going to type this in my calculator. This one probably really is better to type in 2 pieces. Type in the numerator to get 70, the denominator to get 28, and then I'm going to follow whatever rounding directions I was given. Next, we have the median. The median is the middle number in a set of data. Now, you do want to make sure that your data is ordered from least to greatest or greatest to least. It needs to be in some sort of order. It can't be random. When you have an odd number, it's easy. When you have an even number, it's a little bit trickier. We have to figure out what the middle number is. And to do this, we're going to take the average of the 2 middle numbers. So let's look at class 1 and class 2. Class 1 has 6 numbers in it. So that means I'm going to have an even number of data points. So I'm going to take the middle of 78 and 90. So I add those together and divide by 2 to get 84. Class 2 has an odd number of data points. It has 5. Makes it a lot easier. 83 is my answer. I don't have to worry about adding and dividing by 2 because it was an odd number. All right, let's look at a little bit more abstract problem. In this one, we have a class with 5 students, and the median is 83. What happens when we raise that highest number of this list by 3? We want to know what happens to the median. So when I have these abstract problems like this, I like to give it a specific example. So in this case, I just made them all 83. That's a silly example, but the median is 83. If I take that last number and increase it by 3, nothing changes to my median. It's still 83. I'll do another example. Make any list of 5 numbers where the median is 83. Again, just trying to make something specific from this very abstract, vague problem. Take my highest number, increase it by 3. that gives me 88. The median's still 83. Nothing happens through the median. In fact, the median isn't affected by highs or lows. The mean is, though. So if you have a really low score or a really high score, your mean will change. Your median will not. And that makes the median a little bit more stable. Last, we have our mode. The mode is just the data point that appears most frequently. Unlike the mean and median, you could have no answer, or you could have more than one mode. For the mean and median, there's always one answer. For the mode, you have some options here. So let's look back at our Class 1, Class 2, and Class 3 to calculate their modes. Our Class 1 has a mode of 90. It's the number that appears the most. Class 2 has two modes, both 95 and 60. And Class 3 doesn't have any number that repeats, so it has no mode.